Now things are starting to get interesting. What's next? Now I've called it operations, but really and truly what we'll be looking at in this section is simple mathematics. And I'm sure you can make an educated guess from the mnemonics on the screen that we'll be dealing with add and subtract. Now at this point you might be tempted to skip through the next section because you know how to add and subtract. Please watch on because there are some interesting parts to how they work that you will need to know to be able to use them correctly in the exam. Let's start with an example program that will add any two numbers together and output the results on the screen. And this isn't going to be a long program, as you can see. Our first instruction is INP, input. So we'll take whatever the user types in and copy the value into the accumulator. Our user has entered in 100, so that just moves into the accumulator. Line 2 has a store instruction, and this program wants us to store the value of the accumulator into memory location 7. That's the line highlighted in green, and that contains a DAT instruction with the current value of 0. That's going to be overwritten as the value 100 from the accumulator is copied into there. Line 3 is another input instruction, and this will replace the current value in the accumulator with whatever our user types in. That's the number 25, which just pops in. Finally, on line 4 we see our new instruction, add 07. This is the easiest of the mnemonics because it literally means add, and the way it will work is that it will add the value from a memory location to the value in the accumulator and place the result back in the accumulator. Now this particular instruction will add the values from line 7 to the accumulator. Let's take a look at how that works in practice. So it takes the value from line 7 and the value of the accumulator and adds them together. That's 100 plus 25, and it gives us 125, and this value is what's placed into the accumulator. Now we've got our answer to our sum, we have executed line 4 and need to move back to the fetch part of the fetch-decode-execute loop and move on to line 5. This is a nice simple output instruction, so the value from the accumulator will be displayed to the user. You can see here, during execute, it outputs the value 125. The instruction on line 6 is a halt instruction which stops the fetch-decode-execute loop and ends the program. So, a nice simple program that performs addition. And that new instruction is very straightforward, isn't it? Let's use that exact same program, and this time we'll replace the add instruction with our other new instruction, subtract. Now, whereas add was really simple and there's not a lot of places you can go wrong with it, there is a method to subtract that you'll need to remember, and be careful with this. A lot of the written material provided for this is inconsistent or just plain wrong, including the written guide provided on the exam board's website. Anyway, we've swapped out that instruction, but let's rush through the first few lines. It works the same as before. Input takes the value 5 from the user and pops it in the accumulator. Store puts the value of the accumulator in memory location 7. That's the number 5 being put in there. Another input command lets the user put 25 into the accumulator and then on to our new instruction. Let's break this apart and be very specific about how it works. So, the mnemonic sub is telling us to subtract, and the operand tells us to subtract the value in line 7 from the value in the accumulator. Now, it's important we get this order correct, otherwise the answer to our simple sum will be wrong. It's always accumulator value minus the memory value. In our example, that's going to be 25 take away 5. This gives us the answer 20, which, once again, is just popped back into the accumulator. Simple? Certainly. Easy to do the wrong way around? Well, even the exam board can make a mistake with that. Get the order correct in your head and make sure you apply it consistently. Just like in the previous example, our program then goes on to output the value of the accumulator onto the screen, that's the number 20, and then it halts the execution of the program. Well, our collection of instructions is more or less complete. Now we've got mathematical operations added to our collection, and really there's only one glaring omission from this diagram at the moment, and that's that big white space in the control column.